Hi guys, Exter here and welcome to Breakers. This is what the module will look like. This module is somewhat edgework based, hence why I've loaded up two separate Bob instances here. So the aim of this module is by the end of the module we want all of the breakers, aka the coloured ones and the black ones, to all be pointing to the right. As we see they're all currently pointing to the left. We can flip these ones as much as we want, but these ones can only be flipped in certain scenarios. And effectively, we want to get to scenarios where we can flip the yellow one, the blue one, the green one in this case, or yellow, red, and green for this one. So, we must flip all the breakers to the right. So, we'll be using the colour of each breaker here, and the highest digit in the serial number. That's what I mean by slightly edgework based, because I think it's only really the serial number, but yeah. So, let's start with the yellow breaker up here. So the colour breaker is yellow. The highest digit in the serial number, there is only 7, so it's going to be 7. So left, left, right, left. So we can set these to this, but don't flip this yet, because we need to adjust the coloured breakers based on the serial number. Not the coloured breakers, the uncoloured breakers. So we're trying to flip the first colourful breaker. So we're going to look in the serial number and flip the position given when a instance in the serial number happens. And duplicate characters flip the same ones, basically. So we can basically mark all of these out already. So S would be flipping this one. W, flip that one. We have 2 7s, so it actually doesn't matter with these three, because the 7 will flip it and the other one would unflip it again. So we can completely ignore that. Z would flip that one anyway, and X would flip this one. So now we know what breakers we flipped. We actually can see nothing was switched on this one. So if we've done this correctly, we can just flip the yellow one now. Yeah. Because the only serial number character that mattered was the 7, but there was 2 of them, so it flipped it and then unflipped it again. In that case, it would have flipped this one, but then flipped it back again, so we still had left, left, right, left. So now we have the yellow one to the right. We can just ignore it now. It's where we want it to be. And we'd rather not touch it again. So we're now going to focus on the second colourful breaker, which is blue. So the initial configuration is left, right, left, right. Left, right, left, right, yeah. And looking here, the second and the fourth one we flipped. It's actually just left, 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 left. And then we can flip the blue one. And then finally the green one, the initial configuration is going to be left, right, left, left, right. As you can see here. And the black breakers we're flipping is the second and the fourth one again. Second and fourth. So this is the final configuration we have for green. And then we can flip the green one. And now we have all the colourful breakers where we want them to be. We know we did it correctly because they flipped and didn't strike. But the module isn't currently solved because remember we must flip all the breakers to the right. So to solve the module, there we go. Let's do another example. So let's start with this again. Figuring out what we're flipping for the further adjustments first. So we first had D, which flips this one. S, which flips that one. 5, which flips all 3 of these. W, which flips that one. R, which flips that one. And 1, which flips none of them. So we actually got an interesting case where we didn't have doubled up ones, but say we had a 6 as well. We had a 5 and a 6. The 5 would flip this one, and then the 6 would unflip it again. And then if we always had an N, it would flip it again. Which is what it means by each black breaker may be flipped several times, but only the final position matters. Because if you had all 4 of them, that would be 1, 2, 3, 4 flips. Which is the same as no flips, but we just know that's how it works. So, now we have our flips, we can now find the initial configurations for each one to change them. So, yellow, with the highest digit being 5, our initial configuration is left, right, right, left. Looking at the table here, the yellow one will have the second and third flipped. So it's actually going to be left, 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 left. And we can flip that one. Next we have red. The highest digit serial number on any given bomb won't change, so you can basically keep that column highlighted. The next initial configuration is going to be left, 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 right. And looking here, we're going to be flipping the third and the fourth one. So this is our final configuration. Now we can now flip red. Yep. And then finally green. The configuration is we left, left, right, right. And looking here, we're flipping everything but the second one. And we flip green. And now we have all these in the correct position. We can now flip all the rest of the black ones to the right. And we get another sub module. It's quite a simple module in the end, but just be wary of multiple flips and make sure you're focusing on the correct colours of breakers, and just make sure you don't get any of these small intricacies wrong. But that was breakers. Hopefully the module makes a bit more sense now, and I'll see you guys in the next tutorial. I'll see you later.